Hello students, and welcome to another video. Today we're going to be talking about chemical equations. Okay, last time we talked about word equations, and now we're going to start applying some of the chemistry concepts to it. Okay, a skeleton equation is a chemical equation that does not indicate the relative amounts of reactants in products. So make sure to write this down, include this in your notes. Okay, basically we're just talking about what's happening. Okay, let's give an example down here of what I mean by a skeleton equation. So our word equation is hydrogen and oxygen equal water, okay? Well, we can just say those things and it has a meaning to us. But if we're working in a lab and we're wanting to deal with more specifics, we gotta get more specific, okay? And when we talk about a skeleton equation, we're now writing out the chemical formula, okay? We have two hydrogens and two oxygens are now gonna form H2O. Now, the question is why is hydrogen and oxygen have two atoms with them? And that's because they're diatomic, okay? So if I pull my periodic table out, diatomic atoms tend to be the ones in the corner of the periodic table. We have nitrogen, oxygen, and fluorine. And then from fluorine down to iodine are all going to be diatomic. In nature, they're so reactive that they're more stable when they react with something that's the same as them. So they'll react with two oxygens will form a bond, two fluorines will form a bond, okay? And in case you can't quite remember what that looks like, let me draw it on a note card here. So oxygen is going to form 6 bonds. Sorry, it's going to have 6 valence electrons. It's going to make 2 bonds. And if we have 2 of them, right, we can think of that these electrons can share and these electrons can share. So I'll draw it a little bit more clearly on this side. It'll look more like this. It'll form a double bond. And according to the octet rule, this oxygen has 8 electrons and this oxygen has 8 electrons. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay? Oxygen is now much more stabilized. When it's by itself, it's really wanting to fill the holes in its valence shell. Okay, it wants to be like a noble gas. It wants to be like neon, its configuration with 10 electrons. But to get there, it's got to steal electrons. Okay? All right, let's get back to this. So we've got diatomic molecules of hydrogen and oxygen. Oh, and besides the corner, we've also got to include the hydrogen that's up here too. Okay, that one's also in the group. So we've got hydrogen and oxygen, they're diatomic, and then we have water that's forming on this side. Now, if you notice, this isn't balanced. We've got 2 oxygens over here and we've got 1 over here. So we're gonna have to do a little bit of balancing, and we'll get to that in the next video, but we're just talking about in general terms. If we're getting more specific, we're now including these chemical symbols and we're starting to figure out how many of each is being part of this equation, okay? So if we come down here, there's one more picture. This is just describing, in a material state, the hydrogen and oxygen. They're both gases. We store them in tanks. And when we combine them and add a little bit of heat to get that reaction started, we form water, okay? All right, till next time, thanks.